In this chapter, Wiring the Thumb, we're going to look at axis orders a bit more. Axis orders are an interesting problem, and this is something that causes the flipping that we've seen in the twist bones and shoulders. Often people are referring to gimbal lock in animation, where you're getting problems with rotations, and this is because of axis rotations and Euler rotations. Essentially, there's an order for the rotation for any given controller in a rotation. The default is XYZ. And essentially, in simplest terms, it's added up in that order. And like we know in any mathematical equation, things need to be done in order. If they're not, they can be done. You get a different solution. So changing the axis order of an Euler rotation will actually give you a different result in the final rotation. What we're going to do is we're going to work with the axis order to try and make it a little easier for the animator to rotate this thumb and get something that they expect. To start with, we're just going to wire the thumb to the control interface. I actually have 3 spinners now for the thumb to be able to get it, or sorry, 4 spinners for the thumb. The first 3 are actually for this one joint, because there's a large degree of rotation that happens in this thumb joint as it rotates down and around. And then the last ones are for these 2 again. Again, you can break it up more if you like. Let's wire each of those to the given control. So we'll start with the zeroed out X. Hand controls, thumb, go to the first one. Oops, we need a dig to rad. We'll wire thumb 2 to Y. Dig to rad, and again we don't need to go through the process of digging through the quad menus to find everything. We can just connect them directly up. And we now have a thumb rotation set up. Depending on your orientation of your bones to begin with, you might begin to find it a little bit awkward to rotate things and get exactly what you expect. If we start off with default, you'll notice that the first one rotates it around the length of the bone. Next one rotates it in and out, and a third side to side. So let's rotate the bone in on X, down on Y. Then you'll notice as we start to rotate it on the Z-axis, we're almost getting more of a twist out of the X. It's like it's twisting it along the length again. Again, this is an axis order problem. You may actually want the axis order to be slightly different to be able to get you what you want. This is actually pretty good because of the direction the bones are built in the first place. But let's actually check out what happens if we change it. I've left the values on there. We can change the axis order to XZY, for instance, and you'll see that we get a completely different result from the same values. Once again, we have X along the axis aligned to it. Y is up and down. Z is side to side. But now we'll get a different result as we try and do the same set of motions. You'll see that the Z-axis is no longer trying to twist it along its axis. So you've actually got a bit of a better solution here now, because now when I adjust it side to side, I'm not actually twisting the thumb anymore. It's a little bit more controllable just by changing the axis order. So in this case, I've just simply changed the axis order from the default XYZ to XZY, and it's made the thumb a little more controllable for the animator. It's a little more predictable in the way that it works. Next thing all we have to do is simply wire in the final bones for the fingers and the thumb to complete the entire rig for the hand. At that point, you should be able to select the hand, all of its bones and its control, mirror it to the other side, and the mirror object on the other side will already be hooked up for you. We could go about creating poses then if we wanted. Once we have it all hooked up, and store some poses. We never hooked up the end of the thumb. And store some poses for use later. Like I said, you can also write the poses out to a file and load them back on the other hand or on another character. There's more information on my site at paulneal.com about how this tool works. You can also look for updates in this tool from time to time, and they'll be posted there.